Our solar system can feel like a familiar, well-mapped place. We know the planets, we track the asteroids, we understand the celestial dance of moons and suns. But every now and then, the vast, dark expanse between the stars sends us a visitor, a traveler from an unknown shore. These guests remind us that our cosmic home is not an isolated island, but a port on an immense galactic ocean. In late 2024, astronomers detected just such a traveler. Catalogued as 3I/Atlas, this object was the third confirmed interstellar visitor, a wanderer that had journeyed for perhaps millions of years through the cold void before stumbling into our gravitational embrace. And right away, it captured our attention, not just for where it came from, but for what it was doing. This wasn't just another rock passing in the night, it was different. As it drew closer, our telescopes, our tireless eyes on the cosmos, revealed something deeply puzzling. The object was behaving in ways that defied our neat categories. We have boxes for things in space, planets, comets, asteroids. We like our universe tidy, but 3I/Atlas seemed unwilling to fit into any of them. When astronomers at the Asteroid Terrestrial Impact Last Alert System, or ATLAS, first spotted the faint smudge of light, the initial conclusion was straightforward. Based on its path and its appearance, it was classified as a comet. This made perfect sense. Comets are essentially dirty snowballs, chunks of ice, dust, and rock left over from the formation of a solar system. As they approach a star, the heat vaporizes their ices, creating a glowing atmosphere called a coma, and often a spectacular tail that points away from the sun. We expected 3I/Atlas to follow this familiar script. It was an interstellar comet, a cosmic cousin to Halley's Hale-Bopp, but from a different family of stars. This classification was comforting because it was familiar. We know comets. We've sent probes to them, landed on them, and studied their composition for decades. The I in its designation stands for interstellar, marking it as a special case, but its fundamental nature was thought to be understood. Scientists eagerly anticipated watching its icy surface come alive as it neared the sun. They predicted the formation of a magnificent coma, a shroud of gas and dust that would allow them to analyze the chemical makeup of its distant birthplace. Would it contain the same water, the same organic molecules we find in our own comets? The prospect was thrilling, a chance to compare notes with another corner of the galaxy. The moment our understanding of 3I/Atlas was shattered came from the unblinking eye of the Hubble Space Telescope. Orbiting high above Earth's atmosphere, Hubble sees the universe with unparalleled clarity. It was turned toward our interstellar visitor to get the sharpest image yet. What it sent back was not what anyone expected. The image was stunning, but for all the wrong reasons. Instead of a diffuse, fuzzy cloud surrounding a nucleus, Hubble saw something far more peculiar. The object was glowing, yes, but not in the way a comet should. The light wasn't a halo, it was a directed, almost focused emission. It appeared to emanate from a specific point on the surface, and it faded in a remarkably sharp, linear fashion. Imagine a flashlight beam cutting through the fog, rather than a lantern glowing softly in all directions. This was not the signature of sublimating ice. Sublimation makes a roughly spherical coma. The glow from 3I/Atlas was asymmetrical and strangely coherent. Furthermore, the light decreased in intensity in a very specific, non-random way. A comet's brightness can fluctuate as vents open or as it rotates, but normally brightness increases as it nears the sun. 3I/Atlas showed a sharp drop-off that didn't match its solar position. It seemed to be powering down. This added another thick layer to the mystery. Why would a natural object's glow behave with such controlled precision? It was a signal without a clear natural cause, a whisper of something new. The Hubble data sent a shockwave through the planetary science community. Into this arena of scientific confusion stepped Harvard astrophysicist Avi Loeb. Known for his willingness to explore unconventional ideas, Loeb had previously stirred the pot with his analysis of Oumuamua. He argued that Oumuamua's strange acceleration and lack of a visible cometary tail could be explained if it were an artifact, perhaps a solar sail. Now, faced with the enigma of 3I/Atlas, Loeb urged we consider possibilities beyond established natural phenomena. He studied the directed fading light and asked, what if it's not natural at all? Loeb suggested the glow might be artificial. Could we be looking at alien technology, perhaps a derelict spacecraft venting leftover fuel or energy, or something more deliberate? He floated the idea of a nuclear energy source, a decaying nuclear power source, maybe from a billion-year-old probe, could emit heat and light independent of the sun. That would explain an intrinsic glow and why the behavior doesn't match a rock warmed by our star. The hypothesis is extraordinary, but it attempts to explain the inexplicable. Such ideas meet extreme skepticism. Occam's razor favors simpler explanations, and extraterrestrial engineers are far from simple. It asks us to accept that alien life exists, and that it has produced interstellar technology now at our doorstep. Still, science must follow the evidence. When evidence is truly strange, we must consider all possibilities. Loeb pushes that conversation, asking, are we sure it's just a rock? The mystery of 3I/Atlas doesn't exist in a vacuum. It forces us to look back at our first interstellar visitor, Oumuamua, which sped through our solar system in 2017. Oumuamua was also a profound puzzle. It was a small, cigar-shaped object that tumbled end over end. Most perplexing was its movement. It accelerated away from the sun faster than gravity alone could explain, yet it displayed no visible signs of outgassing. There was no cometary coma or tail to give it that extra push. This non-gravitational acceleration remains one of the biggest unsolved mysteries. Now, with 3I/Atlas, we have a second interstellar object behaving strangely but in a different way. Where Oumuamua's mystery was its motion, the mystery of 3I/Atlas is its light. One object moved without a visible push, the other glows without a clear reason. It raises a tantalizing question. Are these two anomalies related? Are we seeing a pattern? When you have only one data point, Oumuamua, it's easy to dismiss it as a one-off fluke, a cosmic oddball of a type we'd never seen before. But when a second visitor arrives and also defies easy explanation, it becomes harder to ignore. It suggests that the population of objects wandering the interstellar medium may be far more diverse and strange than we ever imagined. The alternative, the one that Loeb champions, is that if these objects are artificial, then Oumuamua and 3I/Atlas could represent two different types of alien technology. One, a fast-moving scout powered by a light sail. The other, perhaps a long-haul vessel running on a different self-contained power source. The scientific community is now in a state of heightened alert and curiosity. We are no longer just looking for interstellar visitors. We are looking for interstellar visitors that break the rules. Let's zoom in on the specific behavior of this light because honestly, the devil is truly in the details. A normal comet's brightness is a direct function of its distance from the sun. As it gets closer, solar radiation intensifies, heating the surface, and causing more ice to turn directly into gas, a process called sublimation. This gas and the dust it carries form the coma, which reflects sunlight and makes the comet appear brighter. It's a relatively simple and predictable relationship. Closer to the sun means more heat means more outgassing means more brightness. However, 3I/Atlas refuses to follow this simple logic. The Hubble observations showed its strange, directed glow was fading and fading sharply, even as the object continued its journey toward the sun. This is completely backward. At a time when a comet should be getting more active and brighter, 3I/Atlas was apparently powering down. This is perhaps the single most compelling piece of evidence against the standard cometary model. It's like watching a log in a fire glow dimmer even as you turn up the flames. It suggests the source of the light is not the sun's external heating, but something internal to the object itself. This behavior challenges our understanding of celestial mechanics and chemistry. What natural process could cause an object to turn off its light source in such a controlled manner? If it were a pocket of volatile gas that erupted and then was depleted, we would expect a more chaotic, sputtering decay, not the steady, linear decrease that was observed. The emissions-focused nature is one puzzle, but its controlled decline is another, separate one. Both point away from the random, messy processes we associate with natural bodies like comets and asteroids. Nature tends to be chaotic. This behavior felt strangely orderly. So we are left with a profound contradiction. The object is on a cometary path, but it doesn't act like a comet. It produces light, but not in the way comets do. Its brightness changes, but in the opposite way a comet's should. Of course, before we jump to conclusions about alien engineers, science demands that we exhaust every possible natural explanation, no matter how contrived. So, what could a non-artificial 3I/Atlas be? One idea is a disrupted tidal fragment. A larger body passed too close to its home star or a giant planet and was torn apart by gravity. A fragment was flung into interstellar space. It could retain intense heat for millions of years, glowing on its own. However, this doesn't explain the directed light or its steady decrease. Another possibility, exotic chemistry. Not a water-ice comet, but solid hydrogen or solid nitrogen which vaporizes at extremely low temperatures. It might outgas much farther from the sun, but that still doesn't explain a focused beam or why the glow fades as it approaches the sun. Scientists also considered a recent violent impact. 3I/Atlas colliding with a smaller object in the outer solar system. The collision could expose fresh volatile material or generate enormous heat, causing a temporary glow. The glow would fade as heat dissipates. Plausible, but it requires a very specific recent chance encounter and still doesn't explain the directed emission. Possible, but perhaps improbable. Each natural explanation has merit, but each also has significant holes. They explain some strange behavior but fail to account for all of it. Interstellar origin, directed glow, uncomet-like fading, lack of a diffuse coma. This combination makes 3I/Atlas a tough nut to crack. That's why the conversation remains vibrant and divided. The data pushes us to the edge of our knowledge, forcing us to choose between an unknown natural phenomenon or a truly extraordinary alternative. The beauty of this cosmic mystery is that we don't have to speculate forever. Unlike Oumuamua, which was already heading away from us when we discovered it, we have a front-row seat for the main event of 3I/Atlas. The object is currently on a fascinating trajectory through the inner solar system, a path that will bring it relatively close to the orbital paths of Venus, Earth, and Mars. As it continues its journey, it will get closer, and our view of it will get better. More powerful telescopes, including the James Webb Space Telescope, with its incredible infrared capabilities, will be able to capture images and data of unprecedented detail. The coming months are critical. As 3I/Atlas makes its closest approach to the Sun and then swings past the orbit of Mars, we will be watching its every move. Will it finally develop a traditional cometary coma as the solar heating becomes more intense? If it does, the mystery may be solved. It was just a very unusual comet that took a while to get going. But if it continues to behave as it has, maintaining its sharp, point-like appearance and its strange glow, the mystery will only deepen. Every new spectrum of light, every new image, will be a crucial clue in this unfolding detective story. We will be looking for specific signs. Spectrometers will analyze the light from the glow, searching for the chemical fingerprints of specific elements and molecules. If we find signatures of common cometary gases like water, carbon dioxide, or cyanogen, it would lend strong support to a natural origin. But if we find unusual isotopic ratios or the signatures of heavy, processed metals not typically found on the surface of a comet, that would point towards something far more exotic. We are, in essence, waiting for 3I/Atlas to tell us what it is made of. The suspense is real. We stand on a precipice of discovery. The data we collect in the near future could confirm our place as a lonely outpost of life in the cosmos, or it could provide the first tantalizing hint that we are not alone. Either outcome is profound. Is 3I/Atlas an unprecedented natural phenomenon that will rewrite our planetary science textbooks, or is it the artifact of another intelligence, a message in a bottle that has finally washed up on our shore? For now, we wait, we watch, and